The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Ben Reed here from Rodilec, product specialist for robotics and safety and Banner. Just getting started here. I think we've only got, I think we're still waiting on a couple of people to show up. So maybe we'll give a couple minutes there. Just so you guys are aware, we will be recording this too, so we can share it with you afterwards. And anybody that hasn't yet, we do have another webinar coming up next Wednesday on laser measurement sensors as well. Just give it a couple more minutes here for people to come in. Okay, guys. John and Errol, did you guys want to get started, or do you want to give a couple more minutes?
Yeah, we can get started. Yeah, sure.
Okay. All right,
Go
guys.
ahead.
So yeah, I'll introduce John Klisk, if I am pronouncing that last name right. He is the Senior Product Manager for Safety Products with Banner, and I guess I'll hand it over to you, John.
All right, thank you, and thank you all for joining. Again, my name is John Klusk. I'm the Senior Product Manager for Banner Safety Products, and what that means is I handle all of our safety products. We have a number of them. I'll show you here in a second. I go out and do voice of customer research to understand what new products we're going to develop, and help our marketing team and our engineering teams both build and also promote those products. We have a couple of really game-changing products that we've introduced recently, and a couple that are coming out in the next few months that we're going to talk about today. So before we jump into that, I'm going to talk a little bit overall kind of what we do at Banner. So Banner, overall, our safety objectives are to innovate. So I mentioned I do voice of customer work. Our goal here is to figure out what needs our customers have and find ways to innovate, and keeping in mind ease of use and also delivering value, things that matter to you. So from Banner, our portfolio is pretty big. I mean, you look at what we offer. We have a ton of different safety light curtains that can detect fingers, can detect hands, can detect bodies. We have small versions, large versions. We have grids that can be used to, again, detect body for like entry points in a cell. We have accessories that go along with them, like mute arm kits to make plug and play very easy. We have the two-hand control product, which you probably have seen in a number of factories around the world. This is something we've been known for. We've been doing it for a number of years. Our lighting products integrate very well with our safety products, especially when you couple them with our safety controllers. We have a great range of safety controllers, and one we're going to talk about specifically, the SC10 today. We also have a safety laser scanner we just introduced in the last year. It's a great product, a large full color display on the front to make troubleshooting easy, very easy to use software. We have a number of safety switches, one of them we'll talk about today, and also Illuminated E-Stops. This has been a very popular product because it helps you diagnose where the E-stop was pressed, and you can see that down along a conveyor line or a machine, and these have just been really popular products overall. So that's our overall system. And about a year and a half ago, 2 years ago, I was out doing some research and looking into how we could really do better in the electrical panel. We sell relays, we sell expandable safety controllers, and And as I was talking to customers and seeing what they're doing, we saw a lot of examples of areas where we could really help out and make things really get to that next level, especially on simpler machines. Because we can see in some of these pictures, wiring can be a mess, like down in the bottom left-hand corner. In other cases, they're using a lot of relays where it didn't yet make sense to use a safety controller. And we found a huge opportunity here in this research. And during those discussions, we had conversations with current customers that buy our expandable controller. We call it the XS26. And the overall feedback we received from our customers is they love our software. I mean, that's been the biggest benefit of this product. It's very powerful, but it's super easy to learn and use. And I'm going to show you today. I'm going to go through a demo, and the demo I show you, which will be a matter of a couple of minutes, and creating a configuration. That's about all you need to get started. Our software's free. It's easy to use, and that's a huge benefit of our product. It's flexible for very complicated installations, and even something in the medium to small size as well, because it can have 154 safe inputs, 68 safe outputs. It's smart, so it can do Industry 4.0 communication with Allen Bradley and Siemens with the Ethernet IP or Profinet. It also speaks Modbus TCP, so it's built into our product to be able to integrate and be a smart overall system. But as we're talking to customers that had simpler applications, like the one you see here, where you've got a light curtain that is going to stop the robot temporarily when someone's hand goes in, maybe to add or remove material, that light curtain's connected to a light curtain relay. And then also there's an E-stop that's going to stop the entire machine when something else happens that wasn't expected, and that's tied into a second relay. So in that machine, we asked the question, why not a safety controller? And the answer is pretty simple. When you get down to it, and we're showing list price here. I mean, the prices will vary as far as what you actually pay, but in a list price standpoint, a couple of relays is somewhere in the range of 300 to 500 US dollars. And I should have converted this to Canadian dollars, but it's actually, we'll just call it Canadian dollars for now. And then down here for the expandable controller, it's in the range of $700 to $1,200. So when you get down to it, for that simple machine, the complexity and cost really just didn't make sense. The expandable controller has a lot of benefits. I mentioned that easy to use free software, the number of safe inputs that you get, safe outputs you can pick from 2 to 64 different independent zones, right? So it's very flexible. You can select from 6 amp relays or a 1/2 amp solid state output, and it speaks Ethernet IP. So it's a very, very great system, but it just doesn't make sense on those simple machines. So as we went back after all that research, and we said, okay, we got a number of relays and we can sell them, and they work well. I mean, you've got a product that's basically a mechanical installation. It's got fixed logic. So like we saw before, if I have a light curtain, I pick the light curtain safety relay. If I have an E-stop, I have a different one I pick, and it's just basically plug and play, tie the inputs in, the outputs go out, and it's done. On the expandable controller side, once you get to machines that have 4 or more safety relays, the expandable controller makes a ton of sense. But there wasn't anything in between until now. And that was where we came up with the SC10. This is a hybrid. It's combining the safety controller, so that PC programmable, using the same setup software that we have on the XS26, you can configure 10 inputs on one side. And then for outputs, we have 2 independent 6 amp outputs. So we took 2 of these safety relays and we stuck them in the right side of this box. So here's 6 amp relay 1 and an independently controlled 6 amp relay 2, both with 3 sets of normally open contacts. And this thing does what 2 of these do, but it also makes it so it's flexible. You don't have to be tied to a specific part number that's going to work with a light curtain or with a E-stop. This thing does it all. And with this 10 inputs, you can get a lot more than what's in here. And I'll show you a few examples. And the other thing we're doing is we're going to make the machines that could only use safety relays before smart, make it Industry 4.0 compatible, because this thing will speak Ethernet IP, Profinet, and Modbus TCP to talk to the majority of the PLCs in the market. So what this product is, again, it uses that same free PC software to configure your inputs, your outputs, your logic. It has 10 safe inputs, And for the safety outputs, you've got your safety zone 1, that's a 6 amp relay with 3 sets of normally open contacts, and an independent safety zone 2 that's also 6 amps and also has 3 normally open sets of contacts. And it has industrial Ethernet, so it's smart. It can do diagnostics. It can receive virtual inputs for resets. It has a lot of power, a lot of functionality. And the other thing that we learned when we were talking to customers that were using safety relays is that what they really like about them is it's a mechanical installation. I can take my relay, I can plug my device into it, and it's done. As long as I select the right relay, that's one of the challenges. But so with a controller, they said the last thing I want to do is on these machines, have to get a PC out and program the machine when I build it, or when it goes to the end user and they have to eventually swap it out. I don't want to get a call at 3 a.m. from the maintenance worker to go and figure out how to program it. So we took that back to our R&D team and developed a solution for that. And what we developed is basically it's a little memory card. And what's on this memory card is the safety configuration, the passwords, so it's password protected, and the network information is all stored as a copy on this external drive. So the safety controllers have their own memory, they run off of it. But what you can do with this memory drive is store the configuration for your machine, password protected, the network settings on it. When you go to build a machine, you could pull one of these out of stock. So maybe you have a part number for the SE10 that's in your inventory, and you have 3 different flavors of machines, 3 different types of machines. You could have 3 different part numbers for your XM card, each with their own configuration, password, network settings. The panel builder can then simply take a controller out of stock, grab the part number for this memory drive, stick it into the controller, and it's programmed after a power cycle. It's that simple. There's no need for the control engineer to have to walk out to the floor to go and program a machine before it gets commissioned. And then you can even leave this same memory drive in the controller so that when the product gets commissioned, it's used by the end user, the third shift maintenance worker eventually has to do a replacement of the controller. They simply grab an SE10 out of their inventory and pull this out of the old one, put it in the new one, power it up, and it's back up and running. No need to pull a PC out or call you at 3 a.m. And this same feature works on our SE10 and our expandable safety controller. It's a great feature, and it also, I mentioned network settings, it holds the network settings, so you don't have to go back in and redo the IP address. It remembers whatever IP address was assigned to the controller at the end customer, that gets pushed back onto this memory drive from the controller, so you don't have to go back and do that. It's a very smart system, very cost effective.
Sorry, John, just 1 second. Guys, if anybody in the audience does have any questions, feel free to put them in the chat here, and we will get to as many as we can.
So if you go back to this same machine, so we introduced the SE10 that you saw on this just over a year ago. And going back to that same machine, what we can do with the SE10 is we can take off those 2 relays and replace it with the SE10. The light curtain will take up 2 of the inputs, so that'll be tied to safety zone 1, that first 6 amp relay output. And then the E-stop goes into, and depending on the type of E-stop and what you're trying to achieve, it's going to use 3 to 4 more inputs and be tied to safety zone 2. So in this case, the worst case, you'd use 6 inputs of the 10 inputs on the SE10, so you'd have 4 left over for other stuff. And the other thing you can do with industrial Ethernet is we can speak, Ethernet IP, Profinet, Modbus, and eliminate a button. So if you had a physical reset button to reset this E-stop, you could eliminate this button and do it from a touchscreen HMI instead, saving on wiring, saving on cost, and doing that over your industrial Ethernet connection. And then diagnostics, like shown here, you could have a very dynamic system that tells the user why the machine stopped, where it stopped, and what the issue is over industrial Ethernet without a bunch of wires. So the overall value here is really even on a small machine is a big savings. You're looking at up to $150 per machine cost savings by replacing the relays and the reset button with the SE10 and the virtual reset. This can simplify inventory, by not having to stock a bunch of different relays for your different types of machines. You just stock one SE10. It's configurable. It's very easy to create different configurations as needed for your machines, and it really can simplify wiring. Now, if we go into a little more complicated machine, so this packaging machine has, I believe in this case, it had like 5 or 6 door switches. It has like 4 or 5 E-stops on it and 2 safety light curtains. In this case, you'd end up with 4 safety relays. The reason for that is each light curtain is tied to its own safety relay. Then, depending on how they're setting things up, the E-stop chain would have its own relay. And the reason I'm showing home run cables of each one of these E-stops back to the panel is if you look up here on the HMI, in this case, this machine is displaying the status of each one of those E-stops. And the way they're doing that is they'll run a cable back with the safety on-off wires plus an auxiliary wire to be able to indicate back to the PLC which one is pressed. They do the same thing with the door switches. So what they'll do is they'll run a line for each one of the E-stops and each one of the door switches back to an I/O card on the PLC. So then they'll land each one of those auxiliary wires here, program the PLC so that it knows those inputs correspond to the E-stops or the door switches, and then send that information up to the HMI. The safety wires get tied to the relay to do the safe on-off. So with the SE10, we can get rid of those 4 relays and add in something half the size and a lot lower in cost into the overall system. We also have industrial Ethernet, so we could do that virtual manual reset and other diagnostics from the controller up to the HMI. So for this machine, just with the SE10 alone, there's an incremental cost savings because we're taking out more relays. We're also making wiring a lot, even easier than that previous example, and has all the other benefits that we just talked about. So when you get down to a safety controller, the question is why not now? Because what we have for the SE10 is a product that not only has all the functionality and more, has Industry 4.0, the flexibility, all that, but it's also priced with a list price of $450. So it fits right into a great spot where really there shouldn't be a reason, unless you have a single relay, to not consider this for other machines. And now as we looked at the SE10 and these examples, we noticed the wiring challenge. Customers really want to get trouble-free, easy to diagnose machine, showing what device tripped so that they can just reduce downtime. But the challenge we saw is there's a lot of wires that are run in that system.
So, John, we have a couple of questions here. Someone is saying that ABB and Omron say that we should not use virtual reset on an HMI. Do you heard anything about it?
No, I haven't. Yeah, I'd like to. That's been something that we've done for quite a while. I guess it depend on your risk assessment and what concern they have with that. But having a separate means of doing a reset is the requirement, and it's been in play for a while. Was there any feedback as to why ABB had said that?
No, they just say that you shouldn't do. And also, one thing that is important to remember is that the regular reset is not safe as well. So it's just a regular input, and there is no safety feature on that button. And one thing that is more important than where is it is if it's a physical or HMI is that you have full vision of where are the risks. So when you press the reset, you need to be able to see that there is no one in risk at that moment. So I think that's more important than if it's a virtual reset or a physical button. But I think the most important part here is to say that it's safe, right?
That's right. Yeah. Yeah, those are some very good points, Ariel. Yeah. Any other questions that came up?
So yeah, someone was asking why would you have 3 or 4 inputs per e-stop?
It depends on what category you're trying to achieve with your e-stop. So you can have, so if you want to go with a 4-wire dual channel system where it has the ability to have basically pulsed outputs that are independent for each channel. That gets to your highest category rating. If you could share the pulse in a 3-wire system with those 2 channels is another way to do it. So those are the 2 typical. I mean, there are single channel e-stops out there as well. Our controller supports all of it, so it depends on really what's required for your machine based on the risk assessment. And in our controller, though, it's flexible with whichever configuration of wiring you select or what device you need.
In general, if you need like PLE level, you'd need at least 3 inputs, right?
Correct.
Actually, it's 1 output and 2 inputs, right? So there's one last question here, which is, so in the second example with 4 relays, how can the SC10 duplicate the 4 zones?
That's a good question. So if we go back to this machine, so what they're doing in this case is there's one primary hazard inside the machine. So whether a door opens or the light curtain is tripped, they're going to stop the hazard. The e-stop, so that's one zone. And before, when we had all these relays, the reason they have the 3 different relays for that single safety zone is because of how relays are designed. You've got for this first light curtain, it has its own independent relay. The second light curtain has its own independent relay. It's just how they work. And then for the door switches, because they're set up differently, it has its own relay, but they're all tied together to turn off the same hazard. And then for the e-stop circuit, that's used to kill power to the entire machine because something else has happened where an unexpected issue has happened and someone pressed an e-stop and it's turning off the entire machine. So there's really 2 zones in this system. And what we do with our SC10 is we can get all the safety device inputs into it, tie them to zone 1. So you get the light curtains, both light curtains, and the door switches, and it together and connected to safety output 1. And then the e-stops are connected to safety output 2 or zone 2.
Does that answer your question, Brian? If you still have questions after the explanation, please type again, and we will come back to you.
Oh, Brian says, yeah, that answers his question.
A good question, Brian. All right, so overall, this product has a lot of value at a very affordable price. And when we found, so in addition to being able to solve the relay challenge that we had before and the wiring of those relays, we noticed there's still a challenge here in wiring the devices. So customers that want to do the diagnostics for the device up on the HMI, this wiring setup can be challenging, especially as you get more and more devices. I've had a number of customers that I've visited to show them either the SC10 or talk about other products, and we've had times where our call was delayed because they're troubleshooting a machine, trying to get it out the door, and it was a wiring challenge. And it gets down to, in some cases, trying to figure out what auxiliary wires in this I/O port, the mess of wires that has to come in and be connected on terminal blocks to set everything up can be a challenge. So we have a new feature that we're bringing to market. It's called Banner's in-series diagnostics. And what that can do is it can eliminate this wiring challenge and drop an I/O card from the PLC. We do that with Banner's in-series diagnostics. And what that means is we have devices that can communicate with the SC10. They're connected with simple 4-wire cables, T connectors, back directly to the SE10. Now in the 4 wires that are in this cable, 2 of them are for power, so they go over to the power supply, and the other 2 hook up to the SE10. You can have up to 32 devices connected together in this manner, where you have T connectors and 4-pin cables all the way around the machine. So for all the door switches, in this case it was 6 door switches, they're connected to T connectors and a 4-pin cable, 2 wires go back to the SE10. The E-Stops, starting in August, we're going to have our Illuminated E-Stops that also have this in-series diagnostic feature, and you can connect them, again, 4-pin cables, T connector, back over 2 wires into the SE10. And that simplifies the overall system. And what that can do, not only saving on costs and relays and everything else, but this makes the, reduces an IO card. So it has an incremental savings there versus, doing this with the auxiliary wires. But also the wiring is a big deal. And the other thing we're going to do, so on the HMI before, they could reduce downtime by identifying what device caused the machine to shut down. We'll be able to prevent downtime with in-series diagnostics to be able to alert you when there's an issue with the system before it shuts down. I'll show you more on what that means. So what we're doing here with in-series diagnostics is we have devices that have this protocol built into them, and they send their device information to the SE10, which then goes over these protocols to the PLC and the HMI. So you're getting sensor level information directly on the PLC and the HMI over Ethernet IP, Profinet, and Modbus. And the advantages of that, reducing downtime is something that you could do before, but now we're doing it with simplified wiring. So I can tell you what E-stop was pressed, where it is, what door is open, I can tell you some information about the entire chain. But preventing downtime, this is pretty amazing, because what we can do is, since we're talking from a sensor to the PLC, we can let you know when the door is just at the edge. We're starting to sag, it's still closed, but if it goes any further, it's going to be open. So you can go make an adjustment to the door before it causes downtime. We can alert you if there's a low voltage issue, so maybe there's a power supply problem or wiring issue, and send an alert based on that. It even tells you temperature of the sensor. It has a lot of very good information to help prevent downtime. And then from a cost standpoint, we made it easy to integrate with the PLC. We have a patent pending feature where we can export all the tags for the controller directly to an Allen Bradley or Siemens PLC. And then the setup overall with our software makes it really easy, and our T connectors and 4-pin cables they really simplify things compared to doing those home run cables you saw before. I'll pause. Any questions so far? Otherwise, I can keep rolling.
Someone is asking if IST is based on IO-Link, and the answer to that is no. It's an entirely different protocol.
That's correct. Yeah. So this is it's a banner protocol. What's really cool about this is the devices, the RFID switches and the E-Stops. The 2 wires that come into the SE10 are OSSD outputs, the same OSSD outputs you'd have from a light curtain. But what we do is we send a proprietary, it's a protocol, banner protocol that rides on the OSSD line, and the SE10 is able to interpret the data from that and turn it into useful information that you can use to troubleshoot the system. So it's a really neat system. There's no extra wires required. It uses your same OSSD outputs. And as we integrate this into our Illuminated E-Stops, it makes them, when we talk about the 3 or 4 wire system, it's actually a 2-wire system for the safety portion of the E-Stop, because again, we're using OSSDs now on our E-Stop. So in this setup, we'd have E-Stops with a T connector, 4-pin cables, power goes to 2 pins, and safety to the other, OSSDs and ISD are on the other 2 wires. When you press one of the E-Stops, the E-Stop that is pressed will flash red, and the other ones will remain in whatever state they were in before. So you can visually, locally identify what e-stop was pressed. But then on the HMI and via other alerts, you could send out information to someone to also point out that it's this second e-stop. And now this product I wrote coming soon. I mentioned it briefly before. This is going to be released in August. So today we have our RFID door switches. They're available now, and the SC10 with ISD built in. The system, though, the way it's set up is you can have 2 independent chains of ISD connected to the SC10. Each chain can have up to 32 ISD devices. And they can be set up in any order. So you could have e-stops mixed with RFID switches, if that made sense. So it doesn't matter what devices you have, but up to 32 per chain, a total of 64 ISD devices on this SC10. And if you have the 64 devices, you'd have still have 6 additional inputs available for other things. Like in the previous example, you could hook up 2 additional light curtains. You could use some of these outputs can be converted into status output if you like, to control lights. So there's a lot of flexibility with this, and it's very, for a $450 list price controller, it's very flexible, very dense from a number of devices you can hook up. You mentioned before, Ethernet IP will send the ISD data and other information from the controller out to independent safe outputs. Now, the way ISD will work is if I have on a single chain, so I mentioned 32 devices on a chain, if one of the devices in the chain, like in this case, device number 1 here, this e-stop was pressed, if any device is pressed, the OSSDs for the entire chain are off. What we'll tell you over ISD, it's non-safe, diagnostics, we'll tell you which one was pressed, and we'll tell you a bunch of information about each sensor as well for preventative maintenance. So again, if any of the devices from a safety standpoint are tripped or pressed, the entire chain will be off, but we'll send information about each one back to the system over ISD. Any questions so far on that? And this shows a little more detail about how things are connected. So in a typical system, it's going to be an N plug, a T connector per device, 4-pin cables in between, and 4-pin cable back, single-ended back to the controller. We do have devices. Oh, yeah, go ahead.
Sorry. I guess there's a question here about if when the SC10, when the SC26 will be available with ISD as well.
When the XS26, so that's something that we're working on. I don't have a firm date for you on that, but it'll be sometime next year. Yeah,
it's planned, but there's no due date yet, right?
Correct.
Okay, sorry.
Yeah, and it brings up a good point. I mean, we've had, given the price point of the SC10, the flexibility of it, and the fact that it speaks over industrial Ethernet, we've had a number of customers that are actually already implementing multiple SC10s in a system to meet, whatever zones that they needed. So if you need more than 2 safe output zones, then multiple SC10s can also be deployed. And that's been a very good way to go for a number of customers, but we also see the need for an expandable controller and are working towards that. Now on the chain 1, this shows a little bit different setup up in this area. And what we're doing here is we have devices, ISD devices, that can receive a local reset. So both our RFID door switches and our e-stops will have that ability. So if you want to have a local reset for the specific e-stop, you could select that device, and we have a T connector that allows you to do that. This same T connector is also a way you can add additional power to a chain, because really our limitation on ISD is the 32 devices. And as far as if you want to add incremental power, if you need to, if you have a long, let's say you have a long run or with a lot of devices, you can either replace that termination plug at the end and connect another power supply there, or you can use a T-connector somewhere in the chain and add power. And what's really cool about ISD is we are able to tell you where the voltage issue is located in the chain, so you can figure out where to either add it here or add it down here. And it's a really neat system. And I'm going to show you that here in a second in a demo. And so as far as being easy to configure and integrate, we have the software that I'll show you how simple it is to set up. And then this other feature, to be able to export tags, we can do this for both Allen Bradley and Siemens. We create a file that you can simply import into the PLC to tag all the values from all the diagnostics that we send, so ISD and all the other stuff from our controller into the PLC.
Sorry, John, we got a couple questions here.
Yeah, shoot.
All right, so one question, can we put a door lock on that network?
So a door lock, we don't currently have that in the system. I'm going to show you a device that we'll be adding later this year that would allow a door lock, or a device with two sets of normally close contacts to be added. So I'll show you that in the demo because I'll have a camera, so I can show you a little a sample of it.
Okay, and then can the SC10 talk to each other over industrial Ethernet?
The SC10 do not communicate with each other over industrial Ethernet, but they will be able to speak to that same PLC to send all the diagnostic information to the PLC, and it can also send a virtual reset back to the independent controllers, and there's a couple of other non-safe inputs that can send into it as well, like a mute, enable, disable, etc.
In addition to that, I just want to make sure that we are on the same page here. The Ethernet that the SC10 has is not safe, right? It's just for diagnosis purpose. So make sure you have that in mind. It's not Profi safe or not SIP safe. It's just for Ethernet IP, Modbus TCP, and Profinet for diagnosis, right?
Correct. Yeah. Good point.
A couple more questions. Will the ISD also work on the big brother of the SC10?
Yeah. So I already asked those.
Those were addressed.
Ben.
All right. Sorry, guys, I got disconnected for a second. All right,
No
go
problem.
ahead.
So I'm going to switch over to do a live demo.
I love live demos, and this is so this is so amazing. I really like this demo you have here. I just got mine last week, and it's very cool.
Yeah, I tell you, my kids. So I'm in my home office, and my kids they're 8 and 4. Both are girl hockey players. They're actually awesome players, but they come down here and play with my demo kit quite a bit. And my 4-year-old is asking some really good questions. I was like, kind of impressed. So yeah, we got our own little sales force from my children. But so overall, in what I have going on here in this demo is we got the SC10. I have a light curtain connected in to the system, and actually I'll show on the screen here. This is our software, and I'm running in our live mode. What I did is I hooked the light curtain and an ISD chain 1 together. So the light curtain and the door switches are ANDed together. So like in that machine example, the packaging machine, you could have another light curtain. I just don't have it in here. I have 2 available inputs on this system, where I could have hooked another light curtain in this AND gate to control zone 1. And then down here I have the second chain, and that's the E-Stops. So I have 2 E-Stops in this chain, and I have I'm using actually a hard reset just because it's in my demo kit, and I'm using a light from the SC10. You saw that when I press the E-Stop and reset it, This blue light illuminates because the SC10 has an output that's being sent to it to illuminate it when it needs a reset. So that's the system that we have set up. And what we have for ISD, so chain 1 has 2 RFID door switches that are connected with these 2 T connectors. So it's this T connector with a mounting hole in it. It's very robust, metal QD, very, very good system. They all use the same T connectors. There's an end plug here as well, and that goes into chain 1. Chain 2 uses these same T connectors for this E-stop, and then I just ran a cable over to this other E-stop, and it runs in to here. And what you get with ISD is it'll tell you, when a door is open. So in the system, you'll see that the low-coded system tells you it's open. I can also, and I mentioned that preventative maintenance, I can have my OSSDs are on, this chain is good, but I'm getting a warning, a marginal alert for this RFID switch because it's actually in a state where it's starting to sag. It's still closed, but you need to address it because the actuator is 14.2 millimeters, if you can read this on my screen, away from the sensor. Now, it's a pretty big deal because you can send that alert, go out and adjust it and not have downtime. That prevents downtime. You also see in here, it shows the supply voltage. So it's at 24.2 volts, the internal temperature, 39C. So diagnosing a voltage issue, where we'll send a warning if there's a voltage warning. In this case, we don't because there's just no issue right now, but we can send that out. The other thing you'll see,
So John,
yeah,
just so a comment about the actuator. So I just got a call this week about someone using a regular reed switch switch. And they had a problem with vibration, so it would vibrate and then lock the controller because one of the magnets would go out, but not the other. So one input will be stuck and the other one will open. So they had a problem with that. And then with the ISD, we do not have that kind of problem, right?
that's correct. Yeah. So the switches that we're using here are RFID based, so there's no mechanical moving parts like a reed switch. And so on mag switches, there's a couple advantages, like you mentioned, for RFID. The first one is like you say, is the ability to handle vibration. So since there's no moving parts inside here, this does not have that problem. Another one is if you have any metallic shavings in a certain type of application, a mag switch would not be a great use. And the other thing is, you see the 14.2 millimeters. An RFID switch has over two times the misalignment tolerance of a mag switch. So RFID, if I went to a mag switch, it's between 5 to 7 millimeters. Where on the RFID, you're going to be that 10 to 14 millimeter misalignment tolerance. It's a huge benefit. And then in addition to that, we have in-series diagnostics that's built into here because this is a smart sensor that can speak to the SC10s. It's a really good point. There's a lot of advantages to RFID over mag. Now, we do offer mag switches as well. So if there is, mag switches have the benefit of cost. And so if the application works well for it, we have some great solutions there as well if it's a overall focus on cost.
A couple comments here too, John. Someone saying the E-stop temperature 58 degrees C is hot for an office area.
Oh, so the number that's on here is the internal temperature. Okay. So it's not. I'm not sweating right now. I'm not in the. So yeah, it goes down to the internal temperature of the actual micro in there. But yeah, okay. Good point.
And then someone is asking if that is an S22.
It is.
All right.
And that's the reset button here.
And then someone's saying, comparing Adam and Eve, can you show the range of that 14 mils front to back, side to side for the misalignment?
Yeah. So if you go to any other, I mean, basically the RFID technology is going to be common across the board. I mean, you can approach from from any direction with RFID. That's another advantage that I guess we didn't cover is you can. And if you look at, if you go into the details and look at the Adam and Eve, which I've done compared to our system, there's a very standard kind of, it's like, and you can't really see my fingers, but it's got there's essentially a side lobe to how the RFID signal goes out. Ours is almost identical. The technology is not all that different from an RFID product to another RFID product. The biggest difference is in how we've added this other technology of ISD to speak from a sensor level to the SE10 and also to the PLC. So yeah, you have different approach angles, and as far as the ability to handle misalignment, we're all going to be in the same boat. There isn't really a product out there that's going to be any different. And if you go much more than 14 millimeters, you also have to be careful of somebody's finger getting into that gap, right? So does that kind of answer the question?
I think so. And they're also asking how many can I have in series off of the one controller?
Yeah, so you can have for each chain. So in here, if I've got chain 1, I can have up to 32 devices, ISD devices on one chain. The second chain can also have 32 devices, so a total of 64 into the SE10, and you'll have 6 terminals left over on here for other stuff. And now one of the things, so this will depend on the application, but if you look at, we offer our RFID switch in uniquely coded. That means that the actuator trained to it can only work with that sensor. We offer it in low coded, meaning any banner actuator will work with that sensor, and this is the low coded switch. So if I pull up the ISD information for this switch, you'll see that it's reading in code ACEB. And now if I take this one away, and I've got this uniquely coded actuator from the other one, and I put it next to the low coded switch, what you'll see on here is we'll say that there's an actuator detected, and then the PLC can say, okay, that's great, I see you see an actuator. What is the code? And now it changed to AE37. And where you could use something like that is if you had machines that have like multiple tool inserts for the same machine, you could tie the essentially RFID tag reading portion, and it's just a non-safe thing, but you want to, from a process standpoint, know what tool is there before you run. You could tie the RFID tag value to this one to tool 1, this one to tool 2, and you know from a process standpoint if you have the right tool in place, and you could then tie that into the safety doors on the same chain to also say, are all my doors closed? So tools in place, the OSSDs are on, it tells the PLC what tool it is based on the RFID tag. This door is closed from a safety perspective. OSSDs are on, machine can run as long as the PLC says, yeah, I see the right tool. You could tie that same RFID tag into an E-stop string as well, however you want to do it, but it's a really neat feature because we're telling you sensor level information like the RFID tag value that can be sent up to the PLC.
I got another question here. Are the ISD enabled components compatible with other safety controllers using only the OSSDs?
Absolutely, yeah. So our RFID door switches and soon to be released E-Stops, they're OSSD outputs, just like any, it's a standard OSSD output. You can choose to use the ISD feature with our safety controller. We also have a IO link module, which I don't show here, but what that can do is turn ISD into IO link, and then you can continue those OSSDs to a different safety controller or safety PLC if that made sense. So those are the 2 ways to get ISD information out, SE10 or our IO link conversion module. But if you just want to hook up an RFID switch or an E-stop or even a string of them, you can have 32 RFID door switches or 32 E-stops connected to a standard controller, and the OSSDs will work just fine with the standard relay, with a different safety controller, with the safety PLC. It's all good, it all works. You just won't get the in-series diagnostic data unless you have something that can decode it, like our SE10 or the IO link module. And here you can see, I mean, status-wise, we have, tell you which one is pressed, but one other thing that's really interesting about the system. So if you go into setup, and we've done a number of trials of this system with customers, and if someone forgets the end plug, so I should have unscrewed that earlier, right? But what'll happen is the OSSDs, if I forgot to put this thing in, the OSSDs are going to turn off. So this could either be during the machine build or after the machine's commission. If an end user realizes I can take this out and go on break, right? We will detect that, and as you can see on the screen, it'll send an alert to the PLC to say terminator is missing. So it'll tell you why it's not running. It can also tell you if it has the wrong number of devices. So if somebody tries to wire, let's say you expected to have 3 RFID switches and there's only 2, someone took one out of the system, we'll send that alert to the PLC as well. If you have the wrong order, so if you plan to have an E-stop, then a door switch, then an E-stop, and it sees all E-stops, it'll tell you that it detects something incorrectly there. If the actuator, so like for the uniquely coded system, isn't taught, we'll send an alert to you as well to say, hey, you got to go teach door number 3. So what's really great about that is you think about the commissioning time or the initial build. This is going to help anyone that's doing a build to ensure that they've taken all the proper steps, getting right to the problem so they can fix it right away. So with that, I mean, the system overall is mentioned is really easy to set up. When you go into our software, it's the same for our expandable controller and the SE10. Creating a configuration is very easy. You simply go in. If I'm going to make what you just saw there, I want to add a light curtain. Simply select it. Away you go. For making the ISD chains, you can have up to 32 devices. So in this case, I had 2 door switches. And it shows you where the termination plug is and where the SE10 is. You can give them unique names. Okay, in this case, I'm really bad at typing. So I call that John, that's me. All right, then if you want to add in a second chain of ISD, in this case, we had 2 E-stops. And you'll see there's one other thing that's down here, this ISD connector. I'll talk about that in a second. That's a product that's coming out later this year. I kind of briefly mentioned that. But so you add your devices, and you can simply drag and drop things in this view. I did an AND gate for these 2 devices. So if they trip, if the door switches or the light curtains trip, it'll trigger channel 1. For the E-stops, I did it in my demo kit. I had actual wired reset, but you can do a virtual manual reset. Just select that, run that into a reset block. Simply connect those things and connect that to the output, and my system is done. And now what I can do is simulate it. And I hid some of this stuff over here just for this demo, but you click the simulate button, and you'll see that I need both my door or my light curtain to be okay and the doors to be closed for that first channel to turn on. So that works how I expected. I didn't pick an OR gate on accident, which can happen. And then the E-stop, once that's armed, it's not going to turn that output on until it receives a virtual reset, or if you did a hardwire reset, however you do it. So that works the way you planned, which is fantastic. Then you can go over to the wiring diagram. On here, this shows you where to connect all your wires, and people have just taken a screenshot of this thing and throw it in their own drawings, so it saves a lot of time in that sense. Ladder logic to explain your system to someone else. It's kind of a nice view. And then to select your industrial Ethernet, you can pick Modbus TCP, Ethernet IP, or Profinet, and click Auto Configure. And then that feature I mentioned to export tags, simply give that a controller name, boom, and it creates a CSV file for Allen Bradley, or you can get a different file for the Siemens controller. And your ISD system that you just created, it shows you a summary of that as well. So that's really it. It's that simple to create a system. It's not there's a lot of functionality, a lot more stuff that you can do, a lot of functions, a lot of different devices, but it's very easy to set up, very easy to troubleshoot, and that's really overall the overall system. Now I mentioned I'll go a little more full screen here. I mentioned we had one other device, and that's this ISD Connect. Here's a sample of it, and what this will do, and it's size-wise, let's put it in perspective, it's not a whole lot bigger than the RFID switches, right? So this can be added into an ISD chain, and what you'll be able to connect is something with like a panel mounted e-stop, 2 sets of normally closed contacts into it. You could have locking switches, contacts go into it. You could have a mechanical door switch, whatever you like. This thing has a couple of LEDs to indicate the status of it, and it allows you to use other devices and indicate status. So this is something that we'll have at the end of this year in Q4. But I was just going to do a little sneak preview of that. So there's a few more devices coming in this overall chain.
All right, John, there's a couple more questions and comments here. What is the maximum wiring distance between 2 consecutive devices?
Yeah, on that, so it's really that we don't have a limitation other than there's a 30 meter limit for, if we go back, I'm just going to show the screen here. Okay, so from the last device, between the last device and the SC10, there's a 30 meter limit here. Other than that, there's no limitation, and as needed, you can add power. That's really the biggest thing. So once you get below 19.2 volts, you need to inject power, and it's a very simple method, either using a T-connector or replacing the termination plug.
Okay. Adam and Eve use a positive and negative output when putting RFID switch in series so they can see where the break occurs in line. Is our diagnostic data similar?
So our diagnostic is a bit different. What we do is we actually send a packet of information from each device. So if I go back to this system, the way it works is this. It's actually it's a diagnostic protocol is what we have that rides on the OSSD lines, and it's a patented, unique system. There's nothing else like it on the market. And what it does is it takes all the information from the sensor and it sends it to this one. This one adds its information to that, and so on. So it's a linear daisy chain, and all that information from each device is sent into the SE10. It does some work to make it really easy to read in a PLC and sends that out. So it's a lot more. There's a lot more data that you get with our system, so we can prevent downtime. Like we can alert you when a door's starting to sag. We can tell you the voltage level of the system, and it's not just a matter of saying what device is tripped and where.
All right.
So just want to add something here because I think the question is more on the sense of the actual output. So our devices are OSSD, each one of them, and to pass along that information, so the next device will receive the information from the previous, but that's also safe. So you always adding safe information in the chain. So the previous one send information to the next one that compute itself and check itself, and then send the information forward to the next one. So this is always happening. There is no one device checking for the other. It's just a safe information that goes from one device to the other on the sense that of the safe information, not the diagnostics.
Yeah, that's a good point. I mean, it's like if you're familiar with light curtains when they're cascaded, the OSSD outputs from this device feed into the inputs of the next one, and then its outputs are going to be based on what happens on the one before it, and it sends its OSSDs on or off to the next, and so on. So it's, from a safety standpoint, the OSSDs work just like a cascaded light curtain, and the diagnostic data rides on those OSSD wires.
Yeah, every device has its own safety output. That's important to remember.
Yep.
All right. Someone's asking if you can explain more on the free PC software and application.
Yeah, so on bannerengineering.com, you can download that same software that I just went through and download it today. It's free. We don't charge for software.
All right. Someone's saying it is very comparable to the Adam and Eve, but the software looks much better. Is there any selling key points that you use when battling against ABB?
Yeah, there's a number of the preventing downtime, the alerts that we'll send when we get to a marginal status, the voltage that we send over this, the Illuminated E-Stop is also another differentiator. We have the ability for local diagnostics. We have 4-pin cables that make the wiring simple and have a really robust and cost-effective T-connector. And this SE10, I mean, this is something that nobody else in the market offers. So to have 2 6-amp relays built into a safety controller that's at a $450 list price is unique. And there's a number of other benefits of the SE10 that we went through earlier. So there's a lot there, and it goes back to the way that if we go back to our system is different in the sense that it's a protocol that has device information sent directly to the PLC through a very cost-effective system.
All right, and then one more question. If you do add power, do you need to tie all the 0 volts through ground, or must they be floating? And are the T's compatible with the Allen Bradley SensaGuard?
So the way that you set this up is on the M plug. This device has safety inputs, so you tie 24 volts to the OSSD inputs of the first device. That's all that termination plug is doing, and then connect your zeros together. And as far as the Allen Bradley system, I'm not certain. I completely understand. So I'd have to, maybe we can do a follow up on that one to make sure I understand is it the pinout you're looking for that needs to?
So our T is just a regular T. It's just 4 pins one side, 4 pins on the other side, and 8 pins going up. So that's a T. It's just wires. There's no intelligence there. There's no special device. So I think that's more or less what the question means.
Okay.
I think SensaGuard has a special, just like Seek has a special T where it has intelligence. It's a more like the device that we are bringing in on fall.
Oh, got it. Yeah. So that there's a GuardLink product maybe they're referring to that. So that's a different definitely a different system. And if on the GuardLink, like Ariel mentioned, it's more like this T connector, and what you get with that is just the status of the device. So it's going to be whether it's on or off and where it's located. But since the device doesn't talk to the controller, you don't get a preventative maintenance like the door starting to sag or the voltage level is getting too low, because this device doesn't have the ability to diagnose that. So like if it's sick or if it's Allen Bradley's smart T connector, there's limited information because it doesn't go from sensor to the controller and to the PLC. Any other questions?
They're saying the question wasn't about GuardLink, but they appreciate your knowledge of the competitors.
Okay, that's good.
But I think that's it right now. If anybody else has any other questions, they can kind of hit us after the fact. But I think we are about, we're actually a little over time here, so I don't know if there's anything else.
No, I mean that's really it. I mean you get down to it. This new system, the SE10, is a unique proposition. It fits in between relays and expandable controllers, and with in-series diagnostics, it really changes the game and adds a lot of value. And definitely as we if there are any other questions, definitely feel free to reach out, and appreciate the time and
Yeah, John, thank you very much. Everybody else in the audience too, remember we do have another webinar next week, Wednesday at 11 on laser measurement sensors. Yeah, I think other than that, if there are any other questions, let us know. Somebody's asking, yeah, we have recorded the presentation, so we will probably be posting that on our LinkedIn. Thanks, John. Thanks, Ariel.
Thank you.
Thank you.